The Zoom session is being brought to you by the Fractal Octaves S. All right, for today, 2.1 and 2.2. 2.1 talks about functions, 2.2 about function graphs. A function is a rule. You input a number x, out comes something called f of x. So in a sense, this calculator is a box full of functions. The domain of f is what all the possible inputs are, and the range of f is the set of all possible outputs. You evaluate a function f of x by substitution and evaluation. Here we have f of x equals 3x squared plus 2x minus 4. What's f of 0? What's f of 1? What's f of negative 1? Well, okay, easy enough. For f of 0, you put in a 0 in where the x is. So 3 times 0 squared plus 2 times 0 minus 4. Bit of arithmetic gives you negative 4. F of 1 is 3 times 1 squared plus 2 times 1 minus 4. Bit of arithmetic, you get 1. F of negative 1 is 3 times negative 1 squared plus twice negative 1 minus 4. You get negative 3. So now we can, domains, well, that's where f is defined. So that basically will mean that in this case, there'll be no division by zeros and no square roots of negatives. And this last part, square roots of negatives, will soften a bit when we get to complex numbers. Then we can talk about square roots of negative numbers then, but not until. And as for division by zeros, well, either it'll give you something like 1 over 0, which is too big to be a number, and really it's no number at all. Or it's 0 divided by 0, which is too vague to be a specific number. Really, it's just a euphemism for any number will do. So for example, here's f of x equals 1 over x squared minus 9. Okay, this only has no square roots, but it does have a division. So we want to have this x squared minus 9 to not be 0. That'll be every numbers except plus or minus 3. So it would be this line punctured at 3 and at negative 3. We have square root of x minus 5. Well, this has no divisions, but it has a square root. This x minus 5 has to be at least 0, so x has to be at least 5. So it's 5 inclusive and everything above it. Those are the domains of these two functions. Now, okay, here's something that they go over briefly in this book, but you'll see in much more detail when we get to calculus. Well, not you, not us, but in a later course. If and when you get to calculus, you'll see this difference quotient all the time. The idea is that it's the slope of a line through 2 points on a function's graph. If you have the point here, x by f of x, increase x by h to x plus h. So this point is f plus x plus h by f of x plus h. The slope of this line is the difference quotient, the change in f divided by the change in x, f of x minus f plus h minus f of x over x plus h minus x. This simplifies in the bottom 2. F of x plus h minus f of x all divided by h. This is also known as delta f over delta x, where delta is the Greek letter d for difference meaning change. So it's how much f changes divided by how much x changes. So it's the slope of this line. When you get to calculus, what you do is you let h get approach 0. So this tangent line, this secant line, which cuts through the curve, becomes a tangent line, which touches it at one point. So, all right, and we'll get to that later. So, for example, here we have f of x equals 2x plus 1. So evaluate f at 1, negative 2, a half, a, negative a, and a minus 1. All right, f of 1, twice 1 plus 1, that's 3. F of a negative 2 is twice negative 2 plus 1, bit of arithmetic, negative 3. F of a half is twice a half plus 1, 2. F of a is just 2a plus 1, that's just putting a in for x. F of negative a, well, this is a negative a in here, so you get negative 2a plus 1. F of 2a of a minus 1 is twice a minus 1 plus 1, which is 2a minus 1. Here we have x squared plus 2x. We want to find f at 0, 3, negative 3a, negative x, and 1 over a. Okay, at 0 squared plus twice 0, that's 0. F of 3 is 3 squared plus twice 3, that's 9, plus 6 makes 15. F of negative 3 is negative 3 squared plus twice negative 3, that's 9 minus 6 is 3. F of a, I'll just plug in an a squared plus twice a. F of negative x, well, okay. Negative x quantity squared plus twice negative x. The square here cancels out the negative. This negative, however, comes outside. So you get x squared minus 2x. F of 1 over a is 1 over a squared plus twice 1 over a. Do a bit of arithmetic and algebra, churn, you get 1 plus 2a over a squared. Now here we have something called a piecewise defined function. They're annoying because they're inelegant. They give you one formula for f for some values of x, another formula for another values of x. So for example, find x at -2, -1, 0, 1, and 2. F at -2, -2 is less than 0, so you use this formula, -2 squared, which is 4. F at -1, it's again, -1 is less than 0, so you use the square formula. -1 squared is 1. At 0, however, 0 is greater than or equal to 0. So use this formula, x plus 1. So 0 plus 1 makes 1. F at 1, 1 is bigger than 0. So you use this formula, 1, x plus 1. So 1 plus 1 makes 2. 2 is bigger than 0. So we use x plus 1. So you get 2 plus 1. And that's 3. All right, we find the difference quotient for this thing here. F of x equals 3 minus 5x plus 4x squared. Okay. Well, f of a, this term up here, is 3 minus 5a plus 4a squared. F of a plus h, you put in a plus h wherever the x is. 3 minus 5 times a plus h plus 4 times a plus h squared. Okay, this we should expand. A plus h squared is a squared plus 2ah plus h squared. All that times 4. Distribute this 5 over a plus h, so minus 5a minus 5h plus a 3. Okay, and now we distribute the 4. So 3 minus 5a minus 5h minus plus 4a squared, 4 times 2 is 8, 8ah plus 4h squared. All right, now to take the difference of these two and divide by h. Okay, first I put the 1 over h outside just to make things a little less bulky. And then we have all this here. 3 minus 5a minus 5h plus 4a squared plus 8ah plus 4h squared. All that minus f of a, 3 minus 5a plus 4a squared. Okay, the 3's cancel, the 5a's cancel, the 4a's cancel. These other terms are left, minus 5h plus 8ah plus 4h squared. Dividing each of them by h, you get minus 5 plus 8a plus 4h, and that's the difference quotient. Here we have the cost in dollars of producing x yards of fabric. 15 cost is 1500 plus 3x plus 0.2 x squared plus 0.0001 x cubed. What's C at 10? What's C at 100? What's C at 0? Okay, it's a simple matter of substitution. C at 10, 1500 plus 3 times 10 plus 0.2 times 10 squared plus 0.001 times 10 cubed. After a bit of arithmetic, 1532.1. That's the cost of making 10 yards of fabric. C at 100 is 1500 plus 3 times 100 plus 0.2 times 100 squared plus 0.001 times 100 cubed. After some arithmetic, it's 2100. That's how much it costs to make 10 yards. At 0, you plug in a 0 in here and here and here. These last terms cancel. Now we're left with 1500. The so-called fixed cost of not doing anything at all. All right, so much for that.